Hello, welcome to topic 4.5, triangle inequalities. Here we go. Go to this link if you have internet. Currently don't. Go to this link and see if you can figure out how the three lengths of a triangle work together. So pause, click the link, here we go. All right, welcome back. So what you probably found out by toggling through some of the stuff on this link is that it's called the triangle inequality theorem. Turns out that the sum of the lengths of any two sides, so if I take A and B and add them together, A and B must be greater than C. Must be greater than the length of the third side. This is called the triangle inequality theorem. If you don't understand that, you can go Google triangle inequality theorem and watch a little video on it. So this is, what it means is that A plus B has to be bigger than C. So like this can be 5 and 7, for example. And now C, it can't be 15. You can't have C be 15 here, because 5 plus 7 is not bigger than 15. It could be 9. You could have C be 9. 5 plus 7 is bigger than 9, so that works. And not only that, but also the other two sides. B plus C has to be bigger than A, and C plus A has to be bigger than B. In general, you really don't need to check all three. Really, you just need to check the two smallest. So sum of two smallest has to be greater than the largest. So that really sums it up. The sum of the two smallest sides has to be bigger than the largest side. So for example, is it possible to form a triangle with 3, 4, and 6? Well, the two smallest are 3 and 4. Is 3 plus 4 bigger than 6? I would say yes, it is. 3 plus 4 is 7. 7 is bigger than 6. What about with 6, 9, and 15? Is 6 plus 9? Ooh, 6 plus 9 is equal to 15. That one will not work. Has to be greater, according to the theorem, or else it won't work. It won't make a triangle. What's happening here is that if you went to the thing, if I've got a length of, say, let's call this 4, and then I'm trying to reach out with a length of, say, 1, and I'm trying to reach out with a length of, say, 1 here. By the way, there'd be 4 dots in here, not 3. It won't work. They won't touch. They won't reach out and touch each other because 1 plus 1 is not bigger than 4. Okay? So 6 plus 9 is not bigger than 15. It's like what's happening is you've got a length of 15, you've got a length of 6, you got a length of 9, and they won't reach. They won't make a triangle. That's what's happening. Hopefully you saw that in the link here. All right, 8, 8, and 8, yeah, that works. That's just an old equilateral triangle. 8 plus 8 is bigger than 8. That one checks out. Is 4 plus 8 bigger than 16? No, it's less than 16. 12 is less than 16, so we're gonna give that one a big X, big no. All right, next, find the range. So suppose you've got lengths 1, 6, and X. There's a certain, some X's work and some X's do not work. For example, could you make 10? Could X be 10? Is 1 plus 6 bigger than 10? No, 10 doesn't work. Can X be 5? Is 1 plus 5 bigger than 6? No, 5 doesn't work. So we got to figure out what the X is. There's a little trick here. I'm just going to teach you the trick. If you take your two numbers, you take the small one plus the large one, you get 7. That's the upper bound. All right. And if you take the large one minus the small one, you get 5. You get your lower bound. That's the magical Goldilocks zone here. 5 and 7. Anything above 7 will be a contradiction with the theorem we just learned. Anything below 5 will be a contradiction with the theorem we just learned. X has to be right in the middle of 5 and 7. All right, same thing with this one. You just take your big one plus the small one. Big one plus small one is 30 for your upper bound. Big one minus the small one is 6. So there's your Goldilocks zone for X. X has to be between, if this is 12 and 18 and then the third side X would be between 6 and 30. Next, what is the possible lengths of an isosceles triangle if the base is 10? So here's what that looks like. Imagine you have yourself an isosceles triangle with a base of 10. Here's your isosceles triangle. Is it possible to have a 1 and a 1 here? Is that even possible, or is that not possible? All right. This triangle does not exist. This is impossible. This wouldn't work. 1, 1, and 10 do not work. For the same reason that 4, 8, and 16 do not work. 1 plus 1 is 2, and 2 is not greater than 10. What if I change it to a 4? Does 4 work? Is 4 plus 4 bigger than 10? No. What if I change it to a 5? Is 5 plus 5 bigger than 10? No. What if I change it to 5.1? Is 5.1 plus 5.1 bigger than 10? Yes. All right, so X has to be greater than 5. It can't be equal to 5, it has to be greater than 5. And that's it. We could go up forever. Can you do 7 and 7? Can you do 8 and 8? Can you do 100 and 100? Sure can. There's no limit now to how big they can be, but it just has to be greater than 5. All right. Pause, rewind, review, do whatever you gotta do. All right, next one. This one is gonna be a tricky one. We're gonna use the same theorem. We're gonna solve, the final answer is gonna look something like this. X is gonna have a minimum and a maximum so that we do not make a contradiction. For example, can X be 1? Can X be 1? Let's try. If X is 1, that makes 14, that makes 9, and that makes 3. Can 3, 9, and 14 be the lengths of a triangle? No, because 3 plus 9 is less than 14. So X is 1 doesn't work. What about 2? Does 2 work? All right, let's try 2. 2 plus 13 is 15. 2 times 2 is 4. 4 plus 7 is 11. And 2 times 4 is 8. 8 minus 1 is 7. Is 7 plus 11 bigger than 15? Yes. So 2 works. So somewhere between 1 and 2 is a boundary. Somewhere between 1 and 2 is a boundary. Now, what is that boundary? How do we figure it out? Well, let's do it the long way. Here we go. We know that any 2 sides has to be bigger than the third side. So we're going to do right small. All right, we know that that's true. Any 2 sides, these 2 sides added together has to be bigger than that one. We know that these 2 sides added together has to be bigger than that. And lastly, these 2 sides has to be bigger than the third side as well. That's a lot of algebra on one page. Can you do it? Can you work that algebra out? Let's work it out. We've got 6x, that makes plus 6. It's greater than x plus 13. Subtract the x. Subtract the 6. X is greater then 7 over 5, which is, plug that in the calculator, 1.4. Ah, see, 1.4 was the boundary. We tried 1 and it didn't work. We tried 2, it worked. The boundary was 1.4. As long as we're bigger than 1.4, it would work. So if I plugged in 1.5, it would work. All right, next. Let's do this one. We've got 5x. We've got plus 12. We've got subtract the 2x. Subtract the 12. And divide those out. Negative 5 over 3. Negative 5 over 3 is negative 1.7 when you round it. All right. Now these two, we're going to have to figure these out. Just give it a minute though. All right, next we got x plus 2x, that's 3x. We've got plus 20. We've got subtract the x, I would do, add the 1, and then I would flip it around. I like to think of it that way a little better. All right, so let's put it all together now on a number line. Here's what this is going to look like. Here's our number line, for example. We have x is bigger than 1.4. So imagine 1.4 on our number line. We're going to go like that. We got x is bigger than 1.7, negative 1.7. So that's on down the number line. And lastly, we have x is less than 21, so that's way up the number line. Now we got our Goldilocks zone. Our Goldilocks zone is where all three overlap, so that's there to there. There's our Goldilocks zone. Any x's between 1.4 and 21 are going to work. There we have it. All right, last theorem for the chapter. And that is this one. Triangle sides and angles theorem. Here we go. The largest angle of a triangle will be opposite of its largest side. Largest angle, opposite of largest side. So for example, if this is the largest angle, then this will be the largest side. And if this is the medium angle, then this will be the medium side. And if this is the smallest angle, then this will be the smallest side. It's opposite of the triangle. All right, now we can easily do questions like this. What is the smallest angle in this picture? Well, this is the smallest side. That makes this the smallest angle. 13 is the smallest. That makes L the smallest. Well, L is the smallest. Down here, you might be tempted to say, 52 is smaller than 82. So therefore, this side across from 52 is the smallest. However, you failed to check the angle here. (46). That's the smallest angle. Smallest angle, smallest side. So FG is the smallest side. Next one. Which one of these is smallest? Now I can't use my eyeballs. You might be tempted to try to say, oh, I don't know. It looks like 3 is the smallest. You can't do that. You can't do that. In fact, it's wrong if you did that. If this is x, and this is x plus 1, and this is x minus 1, think through that. That would make this the smallest of these three sides, which would make 3 the smallest angle. And that would make 1 the largest angle, because x plus 1 would be the biggest. B across. Next one, we can solve for k here, actually, because we have angles. Angles add up to 180, or these two have to add up to 120, because 160 is taken. So if I do k plus 2 equals 120, that would work. work that algebra out, which makes this angle 59. What is that, 7? It makes that angle 59, and it makes this angle 61, which now I can make my conclusion. D is the smallest of those three angles, which makes EF the answer to the problem. The smallest side is EF. All right, on the back side, this is, it says, begin chapter 5. We're done with that lesson. And then what we ended up doing in class is just, we worked through some of these problems. So this really isn't part of the lesson, so don't worry about it. This is the important stuff. And that's it. Bye-bye.